like 3.7, we were dealing with translations. All of those equations, however, were linear. So here we're dealing with the parent equation. The parent equation is f of x equals the absolute value of x. So if we see that, that's actually going to look like this. So it actually looks like a V. That's the parent. And then the question is it going to be a shift left and right? Is it going to be a shift up and down? Or will there be a shrinkage or a stretch? That's really what we're looking at. We're going to utilize those same hints and things to tell us. So the first thing we should notice is that it's on the outside. So outside is going to be a vertical. The value is 1/2, less than 1. Anything less than 1 is going to be a shrink of a factor of 1/2. If it was greater than 1, then it would be a stretch. So is a vertical shrink of a factor of 1/2. So graph the function, compare the graph. Yes, find the, oh, did it say find the domain and range? Yikes, I don't think I did that. I did not do that. So the domain is going to be, domain is still going to be, that's my x values, all real numbers. And my range is going to be y is greater than or equal to 0. Yeah, so if we look at that, we know that there's never going to be an output that is negative because all my values are going to be absolute value. But we can have 0. So just understand that I'm going to be able to plug in any x value, but my y values are always going to be above. So my y values are always going to be 0 to positive infinity. So I would write that as y is greater than or equal to 0. Gosh, I hope those questions weren't in the last one. No, they were all real numbers because they were. All right, we're just doing absolute values. This time, it's still on the outside, and we know that that's going to be a vertical, a reflection, sorry. It's going to be a reflection across the x-axis. So that's a reflection across the x-axis. So if we take this and we reflect it across the x-axis, so if we fold this down, we know that our domain is still going to be all real numbers, ARN, and our range this time is going to be y is less than or equal to 0. So 0 can be a solution, but they're going to be below because it's going to reflect down below the x-axis. So reflection across the x-axis. Yeah. Let's do 3. This, again, it's still on the outside. So that's going to be a vertical translation. And it's going to be a vertical translation. Remember, vertical is up, down. Horizontal is right, left. So because it's on the outside, it's going to be vertical up and down. And it's going to be down 3. And so what's it going to do? It's just going to take this and it's going to shift it down 3. So it doesn't affect my inputs. So my inputs or my domain is still all real numbers, but my range is going to shift down. So if it was 0, it's going to be y is greater than or equal to -3 because it's going to start at -3 and go up. These are great questions. Now, again, this isn't your typical Algebra 1 questions. This is more pertaining to Algebra 2. You will see these questions in a typical Algebra 2. I doubt you will see a question asking for translations on any placement test. You may see it in star testing because star testing will go outside of the Algebra 1 concept band and it will reach into geometry in Algebra 2. So you may see it on star, but I doubt you will see it on any high school placement test. All right, now this problem, now we're inside. So remember, inside's going to be the inverse. It's going to be dealing with the horizontal. So horizontal translation. And remember, horizontal is going to be right, left. So it's the opposite of what we see. So it's going to be left, that's my negative, 2 units. So if we go back to this, if this is the parent and its inside, it's going to move it 2 units to the left. So a horizontal translation, 2 units to the left. So that doesn't change my domain. My domain is still all real numbers, even though it shifts to the left. And my range is not going to change up and down. My range is still going to be y is greater than or equal to 0. So even though we shifted, it still goes to positive and negative infinity. That was number 4. So number 5, okay, looking, so this is the first time. Remember how they tricked me? So this time they changed the parent. So on the last number 12, I think it was, on 3-7, I made a mistake. I didn't notice what the parent was. So that's the parent. What's the only difference that's happening to the parent is this piece. So still inside, but it's only one thing. So inside is going to be, it's a vertical, it's being multiplied, but it's inside an inverse, so this is going to be a vertical stretch of a factor of 4. So it's a vertical stretch of a factor, sorry, not vertical, inside, horizontal, sorry, I know that some of you, horizontal, sorry, it's inside, so horizontal, and then I knew the inverse, so stretch of a factor of 4, my bad, sorry. All right, so 2 things to be careful about with that. Make sure you understand what the parent is. So we see this is the parent, so we see that. So what's the only thing that's different? Oh yes, and this is the parent also, sorry. So that's the parent. So the only difference is that. So that is inside, it's multiplying, it's inverse. There's lots of things to keep track of. So it's a horizontal shrink of a factor of 1/3, because that's the inverse of multiplying by 3. So that would be a horizontal shrink of a factor of 1/3. Good. I like these. I mean, they're kind of technical, but they're fun. So we notice what the parent is. So what's happening? Now we have 3 things. We have that. We have, no, let's change colors. We have this. And then we also have this. Woo! And some of them are inside, some of them are outside. Let's deal with the outside. So first, that is a reflection across the x-axis because it's outside. Reflection across the x-axis. That's 1. It's going to be a outside -3, so it's a vertical translation, 3 units. Vertical is up and down, down, 3 units down. And then it is a, that was that one. Now we're here. That is a horizontal. Horizontal, and it's going to be the opposite. Horizontal translation. Horizontal translation, 1 unit up. Because remember, horizontal is up, down. Vertical is, no, sorry. Yeah, horizontal is up, down. No, that doesn't feel right. Sorry. Vertical is up, down. I kept writing it and I knew that wasn't. Horizontal is left and right. So left, right. So if I'm on the horizontal translation 1 unit, I want to go to the opposite. So that's going to be 1 unit to the right. So horizontal translation 1 unit to the right. Good. All right. That took me, you got to slow down, do it right. I mean, there's a lot of complex, complicated things. That's why I write it down. That's why I refer to it quite often. So that's 3 units is blue, and purple is going to be that one. I hope we have one more. Do we have one more? Yes. All right. So the only reason I want one more is so I can make sure I'm doing it correctly. So here's my parent, starting with that. So let's deal with the inside. So let's deal with these things and this thing. So let's start with, I don't know, let's start with that. So that is inside. So it's a horizontal. So it's going to be the inverse. So it's going to be a shrink of a factor. The inverse of 2 is 1/2. Factor of 1/2. Let's write of 1/2. That's 1. Then it's going to be a horizontal. I didn't remember the horizontal. Now it is a translation. And that's going to be 4 units to the left, because that is the inverse, and horizontal is left and right. And then that's that. Here we have a vertical translation of 1 unit up, because vertical is going to be up, down. So let's check it, make sure. Horizontal translation 4 units left, good. Horizontal shrink factor of 1/2, and then a vertical translation 1 unit up. Yes. Let's go. All right. The point A, B, and C lie on the graph of the absolute value function. Find the coordinates of the points corresponding to A, B, C on the graph of each function. So, okay, so this is, we can do 2 things. We can plug it in. We can plug in the x value, calculate it. But we just know what this is. So this is on the inside. So that is just going to be a horizontal translation. And that is going to be a horizontal translation of 5 units to the left. So when we say A is 1, 1/2, A prime, we call that translated point, A prime, that's going to be So it's 5 units to the left. So that's -5. So we're going to have -4 1/2. If we shifted it over, if we subtracted 5 from 1, you get -4. Let's do B. So the B point was 4 -4. 4 -4. And that's going to be a 5 left. So it's -1 -4 would be my B prime. And my C point, what is my C point? 6 -1, 6 -1, 6 -1. C prime is going to be 2 -1. Oh, sorry, 5. 1 -1. Did I do that correct? Yeah, good. So those are the 3 points. Find the coordinates of the points corresponding, so those would be its corresponding points. All right, let's look at the next one. So we know it's on the outside. So outside is going to be this, and so this is going to be a vertical, no, it's going to be a reflection across the x-axis. So A is 1, 1/2. So A prime is going to be 1, -1/2. Right, I think I did that now, huh? It says -1. I think that's incorrect on the, I think the book answer is incorrect because for -4, B prime, it's only affecting the output is going to go negative. My input's still the same, so I input 4, but this time I'm going to reflect it. So if it was under, it's now going to be above. So that's going to be 4, 4. And C, what was 6? 6 -1? 6 -1. And so C prime is going to be 6, 1. Yeah, they made a mistake on the answer key for A prime. Reflection across the x-axis. Good. All right, this is going to be a stretch. It's outside. It's going to be a multiplier. So this is a stretch factor. It is outside a vertical stretch factor of 2. So think about it. We're just multiplying our outputs, our y values. So if A is 1, 1/2, A prime is going to be 1, 1. And B, if B is 4, -4, B prime is going to be 4, -8. And if C is 6, 1, 6, -1, then C prime is going to be 6, -2. Cool? Cool. All right. Sketch graph of an absolute value function that has a vertex of -2, -3, and x-intercepts of at -3 and 1, and then write the function representing by your graph. Okay, sketch a graph of an absolute value, so we know what that looks like. So it's going to be a traditional, so it has a vertex of -2, -3, and then x-intercepts at -3, so x-intercepts crosses the x-axis at -3, 1, 1, 2, 3, and -1. That's correct because this vertex actually acts like an axis of symmetry. So absolute values have lines of symmetry, and they're going to continue. So we would only assume that this graph looks like this, continuing with that slope, because I didn't do that. Come on. Because they are linear to a certain degree. Let's do this. Let's change that color. Change that color to green. Red. I like red. Okay. These are going to have arrows because they go on forever. Let's make sure that it continues to have a slope of 3, 3, 3. That's good. 3, 1, 2, 3 there. 1, 2, 3 there. 1, 2, 3. Yeah, that's good. Okay, so that equation is going to look like f of x, doesn't say what it's, f of x equals 3x, that's the slope, and then it has a y-intercept of 3 plus 3. So is that equation? Oh, absolute value. Whoops. Sorry. My bad. So 3 is the factor, and then it's a shift. So we could look at the shifting in that sense. So the 3 on the outside is the slope. This is going to be my slope right here. That's that. This is inside, so because I went to my vertex is -2, that point is -2, -3, because I went left 2 and down 3. Did I go down 3? Well, no. I don't care about the down. I went left 2, and then, yeah. That should be -3, yeah. -3. I went to left 2 and down 3. So left, because that's the inside left is horizontal, is left right. That's going to be inside. Up down is on the outside. That's why we went down 3. So that is the correct. That's the correct equation, and that slope is going to be outside. I don't know why, because it's 3, because it's a stretch factor. I don't know why I would know it was outside. I don't know. That's a hard one. It's a good one, but it's hard. But those are the things that you should keep in mind. Again, this is a lot of Algebra 2 stuff. The absolute value, graphing absolute value, is definitely something you will see in Algebra 1. But the shifting and all that, probably not. That's where it gets introduced. So good luck.